Imagine uploading a PDF and instead of reading through pages, you just ask questions and get instant accurate answers from it. In this video, I am going to show you how I built a RAG chatbot, a system that does not just guess like normal AI, but actually reads your document and answers based on real content inside it. We are going from PDF embedding to vector database and finally to the chatbot itself, powered by a large language model, LLM. I built this system using Python, Streamlit, ChromaDB, and Ollama. And by the end of this video, you will understand exactly how it works and how you can build one for yourself. Before we get into coding, I would like to show you what to expect at the end of this video. So this is the user interface, and in this user interface, we have the upload, then we have the process data. So when we upload a file, let's upload this file and we process it. You see that we get to see the steps that it takes in processing this particular file, from the page extraction to the chunking to the embedding, and then to the indexing on the database, that is putting it on the database. So when you put a file on the database, like this PDF file we just put in now, and you query the system, what is this document about? So you get a response based on the context being withdrawn from the database. So if you can see this response, it says based on the post and provided context, it appears that the document is about wildlife. Of course, if you look at the name of this document, you see that it is wildlife ecology.pdf. So you are going to get a response according to the context being withdrawn from the database. Each of the PDF maintains its own chart. That means the chart from this particular PDF does not get to this other PDF. So each of the PDF has its own chart, and any of the PDFs that you've not charting remains empty. If you look at these stories for children, we've asked what this book is about, and it provided us based on the context it retrieved from the database. Now you can delete any PDF you choose to by just simply clicking the delete. Once you delete a PDF, it deletes the chart on that PDF alongside the PDF itself. And you also have the option of clearing charts if you want to. You can clear charts, and once you clear the chart, that particular chart of that PDF will disappear. That does not make it affect other PDFs, but just for the particular PDF that you clear this chart. Also note that when you try to upload a PDF that you've uploaded before, for example, this wildlife ecology, if we try to process the PDF, it will tell us that this PDF is already loaded in our system. If you look at, we have the active documents. Currently active document is the stories, short stories for children. So this part also shows us which document is currently loaded. This is where we chat with the PDF and get our responses. So we are going to be looking at how to do all of this in the code sections, from the extraction of the PDF to the chunking of the PDF to the embedding, straight down to the indexing, that is putting it on the ChromaDB database, and finally querying the system. So stay tuned and feel free to subscribe, like the video if you learned anything, and also comment in the section if you'll be trying this video, if you'll be trying out this project on your own. Alright, coming to the code aspect, I'm going to first of all be going through the file structure and different scripts that make up this particular app. So we have 9 different scripts: the app.python, database.python, helper.python, ingestion pipeline, class base, I just named it that, RAG phase 1, RAG phase 2, So this is just the structure. I have a folder that contains the necessary modules we'll be needing. I also have a JSON folder. Then I have the database folder. And this folder contains the PDF files. And then this particular folder is not supposed to be here, but it was for test purposes. So quickly, I'm going to be running down through each of the Python files, one after the other, so that we understand what's going on. So first of all, under the Python, the app.py, this is the main interface. This is the UI interface where you interact, where you build your app, your Streamlit app. This is where you build it. So we start by importing the necessary libraries. We import Streamlit, we import temp files for just temporarily holding the PDF files that we upload while they are being updated into our database. We import OS, we import UUID, time, JSON, database. This particular database, from database import metadata.db. It's a particular folder which is the database folder. Those of us who are familiar with coding with Python, you will know that you can have two different scripts and share functions uh, between the two scripts, whether in class based or just functions ordinarily like that. But in this particular project, all our functions is class based. I use classes so that it can easily be reusable and easy to, communicate among different uh, Python scripts. That does not mean if you use functions, that's bad. No, I just prefer using class based. So we have the helper. From helper, import delete from Chroma. I think this was the only file where I used function based script. So we have from ingestion pipeline, import PDF ingestion pipeline. So this particular script has to do with how the PDF file gets imported into the system, how it's chunked, how it's embedded, and finally how it's uploaded into our database. I'm going to get to all of that from RAG phase 5 query answered class based import local RAG pipeline. So this particular file, this one here, is basically how we query when we query the system, how the query gets embedded. First of all, the query gets expanded. What do I mean by expanded? When we get there, I'll explain better. The query gets expanded, then the questions get embedded, then those embedded questions pass through what they call a hybrid retrieval, whereby we have a semantic retrieval, and we also use the BM25 to filter our results from the database, and before we pass it into, then we re-rank. Don't worry, when we get to that, some of the scripts, I'll show you how we re-rank the chunks that are being extracted from the database to make sure that these chunks are being arranged properly and also avoid duplicates. We're going to be seeing all of that. So basically, that's what this particular pipeline does, the local RAG pipeline. So this app.py is just for the user interface. This is where everything gets connected to. So first we have the page configuration where we set up the Streamlit. We have the title of the page. Then we created a JSON file that stores the history of the users, as in sorry, of the messages that goes through between each PDFs. Let me just quickly open the JSON file so that you see what it's like. We've chatted, I think just very few chats, just one chat is here. So this first numbers and letters combination is just like the PDF itself. That is where you see the document ID. It's on the UI. I'm going to show you when we get there. I'm going to rerun the project when we get there. All these are the PDFs. Then The messages in the PDFs are what is now here. You can see the role, user, content, what you asked, what is this document about, role assistant, this is what the AI answers you based on the provided context, blah, 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 like that. So this is where it stores. This is what makes the user chats between the user and the AI. That's what makes it persistent across different reruns. That means you don't get to lose data. But please note that this can be improved in many ways. This is not the last result for handling chats. It can be improved in many ways. If you want to know how it could be improved, just ask me in the comment section and I'll reply. It could be improved in many, many ways. You could embed it, you could upload it online, different ways it can be. But for the purposes of this project, I'm gonna be doing it like this. So quickly, this is now where the database. Now, this particular database is not the ChromaDB database. This particular database handles the file name. It handles the um, basically the file name because that's just it's linked with the ChromaDB. All I did is just like look at it this way. The ChromaDB stores the vectors of the vector embeddings of the PDF, then the database, that is the metadata base, just stores the metadata of the PDF. Example, the file name, the document ID, the number of pages. We'll get to see it as we go through this project. We're going to see what this DB, the database, stores. So this particular function here is just for the chat history storage. We get to open a new file. In case the file doesn't exist, we create the file. Then we open it in read mode. Then we dump some JSON file in it, except we return. So this particular function basically just creates our history file, which I just showed you, our JSON chat history. It creates it and begin to dump all the histories that we have there. That is what this particular other function is for, save chat histories. So we begin to dump all our histories whenever you chat or whenever the AI replies rather, because the files doesn't get saved automatically when you chat. It's when the AI replies, that's when we get to save the file. So this particular section is just initializing the sessions with Streamlit so that we don't have to always be going back to the memory of your system to access things like the messages, the document IDs, the active PDF. All these things are just saved on the RAM for easy access. Some of us that read computer engineering knows that accessing information through the RAM is better than is faster rather than accessing it through the ROM. So accessing it through the RAM, you have some extra benefits. Accessing it through the RAM than through the ROM is much way faster. So this particular function, what it does is that it's just for status update. When you upload a PDF, those details that get shown, that's what that function does. Where are you? Okay, here it is. So that's what basically this function does, the display. So when we get to each of these from the rack phase one that does the extraction of the PDF to the chunking to the embedding to the adding to the database, I'm going to be showing you how all this came to play. If you want to study it more, you could always go to my GitHub. The codes are there and you could pick it up and you study it better. So this is basically what this particular function does, updating the UI so that the user can have a visual of what is actually happening at the back of the code. So that's what this particular place does. All to this place, return callback, that's what it does. And this particular part is when we want to delete our charts. This is the function that get called when you want to delete your chart from any PDF. We get to check the chart history, then the document ID, which particular document are you deleting its file. Then we call this save function so that we can actually save the other chat histories that are remaining back to the system so that you don't get to lose everything. So load all chat histories. So this is just like when the system is about to start, you load the chat history so that everything will be in the RAM and ready to be used. Then you say build a short memory. So this is basically, I wanted to use this to, give my LLM, whenever I query my LLM, I wanted to use it to like give it a backtrace of the messages that it was receiving. But I noticed that when I did that, my LLM seems to malfunction. I don't really know why it did that, but I noticed that once I remove this particular function, calling this function into my LLM, I noticed that my LLM did way more better. But you could play around it, add some few tweakings you can add to it. But for me, this particular function didn't just work, so I ignored it. So please ignore it. Probably I forgot to delete it before making this video. So of course, I forgot to delete it, not probably. I forgot to delete it before making this video. So this particular function is just to load document chart, the particular chart that you want to load. Now, if you look at it now, we are accessing it from the session ID. We're not accessing it from the RAM. So this will way be faster than accessing it from the ROM of the system. So we are just loading the charts. Each time you load a document, you load the chart. Each time you load a document, for example, just like the beginning of the video where we load the Nigerian Constitution, we load the charts that we've had. But if you've had no chart, obviously nothing is going to appear. So this is just to save document chart. By the time you are done by every chart, it saves the chart that you did. So this particular sidebar is what we see by the side of our UI. Let me run this project so that I could be showing us exactly what I'm trying to do. So this sidebar, from here you see, okay, it's coming up. So this is it. What I was trying to explain. When we load up the sidebar, this is the sidebar where we have the upload. That's where we get the upload. You said header, upload PDF, this information here, and this is just for the sidebar. Everything in the sidebar, this is where we get it. The set.divider, this is it. st.divider, this is it. Then we load our available PDFs. This is where we get to load our available PDFs. Then after that, we have the delete buttons. These are the delete buttons. This is where we get to delete any document you want to delete. This is where we delete it. So you could actually, go to my GitHub, get this code, study it. It's not rocket science. It's quite very easy. But please, let's always know that these are not for Python beginners. So if you're just starting to learn Python, I won't recommend you going through this project because you might get really confused. So for us to clear our chart, remember, just like I told you, you could always clear your charts without actually messing with the messages. You could clear your chart without messing up with the messages. Let's see, okay, like this particular PDF, we had some few charts here, so we could actually come here and clear the chart, but the PDF still remains. So we could actually chat with this PDF again. So that's just it. So st.rerun is just for us whenever we do anything in the sidebar, the whole system just gets to rerun. So finally, we divide our layout, the left side and the right side. So this is actually coming to this particular area. This is the left side, this is the right side. So this right side is where we want to be displaying this is the document ID that we talked about in the JSON file. This is the document ID. Every file has a different document ID which is unique to it. This one has its own, which is very unique to it. So these help with the bookkeeping in both the database and in the ChromaDB. So this is where our current file gets reloaded with the right column. So towards the right, we see the document that is in session, and we see the name of the active PDF, and we also see the number of messages that has gone through our PDF. The number of messages that we've had with a particular PDF. Okay, so this particular portion is for when you upload a PDF and then you want to process that PDF. So when a PDF is uploaded and you want to process it, so we get to run this particular section where we get to call the pipeline. This is where we get to create the document ID. In this particular place, we get to create it. Remember, this is the purpose of that temp file I initially spoke about, that library we initially imported, just to save the document temporarily while it's being processed. So we get to call the pipeline in this particular place. All these ones are just loading up document history. This particular portion of the code, this particular block, is to check if the document already exists in the database. If it does not, then we can move forward. We can move forward by, when we move forward, we now have this our spinner that says processing PDF. This may take a moment. This is where we see then with container. Now, why we are using with container here is so that the whole message doesn't just jump pack in the UI. It gets to be, that beautiful animation you saw when it's done with page extraction, it turns green. It's done with chunking, it turns green. So it's the container kind of enables keep that very clean. So this is where we call the pipeline. This is what we call the pipeline. The pipeline is the injection. This particular file, this is the pipeline PDF injection pipeline. So that's what we get to call it, this particular block of code. And we get to pass in a lot of parameters into it. We get to pass in the file name, the file ID, the collection name. The collection name has to do with our Chroma DB. We're going to get to see that. The PDF file path. Then this particular portion is just for callbacks, for us to see the interaction going on, actually what's going on at the back of the code, so that it doesn't just seem as if our system just hanged or something. So this is where we get to store the result of the pipeline. So we just say pipeline.run. So this is where we get to run the pipeline.run. So this is it here. Then after this, we create the particular session. We create the particular session with the document ID, the active PDF. We set it to the recently uploaded document. Then PDF ready, we set it to true. Then the messages obviously is empty, so it's going to be empty. Then remember, save document chat. We begin to save the document. This is where this document portion gets created in our chat, in our JSON folder. Just like I told you, this is the document ID. Remember the file we deleted. If you can see, we are no longer seeing anything here because it's been deleted, it's been updated. So this is the file ID. It's very important that we are careful with this files. It's not normally good to just leave it open like this, because once you delete anything here, it messes up with the whole database. You have to delete your entire database and redo everything, or you have to get back that particular document ID that you missed. So this is just the cleanup. Why are we cleaning up? So as to make we don't have unnecessary background runs in our UI. So we unlink the path, and then we simply say we have a successful run. Then we now have st.rerun. Now the reason why we are rerunning the st is to clear that particular user interface, because if we don't do that, you will see that those messages that we got while our PDF was loading will just stay on the screen, but we don't want that. So that's why we run. So I'll have a blank sheet again. Then towards the left, all we're just doing towards the left is just appending our history, our chat history. We're just appending it to the user interface. Then chat input, this part is where we input our chat. This session, the PDF is ready. When we have a PDF that is ready, it activates the prompting. We begin to send in information into our prompt. We save that into we append that into the session messages so that it can always update. Then with left, towards the left, remember as I told you, we have the right side and the left side. So we are working towards the left now. So towards the left is where our messages get uploaded to, and each time we upload a message, we now call this rag function. When we click enter, we call this rag function. Now this local rag pipeline, this is what it runs. This is where our query gets sent to, and we get our answers. So stream chat. So this is just one of Ollama's ability to stream chat. When you see the chat coming out as if it is typing itself. So this is what gets to make that kind of give us that feel that it's actually typing. And then we have to save what the AI has given us. Remember, just like I told you, it's after the AI has responded, then we now get to save that particular chat or that particular message session. So what makes up one message session is when the user asks and the AI responds, and the RAG system responds. That makes up one session of chat. So that's what we get saved here. So else with left, upload your PDF. That is if we do not have, remember, we have something here. If PDF is not ready, that means if we don't have any PDF loaded or uploaded, this is what should be displayed in upload or select a PDF. So that's just it about this particular script. As I said, you can always go to my GitHub, get this code, study it better. Then we have the database.py. This particular database is just to save the file name. Okay, look at it here. We get to save the ID, the file name, the collection name. Now, the reason why we're saving this particular collection name is for us to be able to connect it to our ChromaIDB. Remember, in our ChromaIDB, we have what we call like a collection. That collection name is what comprises of, it's just like a library. Yes, I think that's the right word. It's like a library that contains books. So which particular, we can create different libraries in our ChromaDB. So when you want to now access the library, you have to pass the name of the library. So the name of the library we're going to be using here is PDF rag. So this particular, the reason why we're passing this is for us to know the particular library. Remember, I told you that this database is linked to our ChromaDB rather. So this one is just to upload the time and when that particular message was created. Then this particular function is to get all documents, what documents are on the database. So it's going to fetch everything. And this one is to get single documents. So if we want to get a particular document, this is where we use the code. Some people who are very familiar with SQL codes will understand some of these terminologies where it says select asterisk from document, that is select all from document, where document ID. So it's going to fetch everything about that particular document, everything about it, the file name, the vector, sorry, not vector, please, because we're dealing with database here. The file name, the collection name, where the collection it's in, the ID, of course, which we've already passed in here. If there's a summary, it gets it. If there's a number of pages, it gets it, and stuff like that. So this is when we get to delete a document. This is what we use in deleting a document. But then this particular function, just like I said earlier, is what links us to the ChromaIDB. Remember, these are two different databases. One of the database is used to store the vector embedding, and then the second one is used to store the metadata. Remember, the ChromaDB stores metadata too, but It's just a personal decision. All this thing that is done here could also be done on the ChromaDB, but I want to separate them. So one is stored in the SQL database, and then the other one is stored on the ChromaDB. Remember, the ChromaDB, I think it also uses SQL for its own database. So this is where we get to close our database. So under the helper, as I told you, this was the only script where I had to just use function, and I believe because it was just one function. And now what does this function do? Some people might be saying, delete. So it is actually for us, whenever we delete a folder, that folder should also be deleted on the ChromaDB database. So that it doesn't just only get deleted in the SQL database, it also gets deleted to the Chroma database. So basically we connect to the ChromaDB database, we get the collection, then we get to delete by document ID. So that we get that particular document, delete all the vectors on that, so that our ChromaIDB, once we are deleting from the SQL, it's also deleting on the ChromaDB. So that's just what this function is for. I think this was something that just came to mind towards the last part of my project. I just decided to drop it here because I was noticing that my delete just get to happen on the SQL. It didn't happen in the ChromaDB, so I just had to link them. So that's why I had to just create the script. Helper, I didn't want to start going through the process of making it a class and stuff like that. I didn't just see the use. So now, ingestion pipeline, class based. Forget about my naming. You can make yours simpler. So this is where all the PDF uploading happens, both the uploading of the PDF to the Chroma database and uploading into the SQL database, which is our normal database. This is where it gets to happen. So from this particular script, I broke it down. So let me first of all go through each of these scripts that is in this injection. So I'll go through this first one, which is the page extraction. So the page extraction, the particular module we're using for this page extraction is PyMuPDF. So PyMuPDF, just like it's written on the screen, that's what we're using for this particular project. But let me write it here. So we are using PyMuPDF. So this is the particular library. Thanks to them, this project was possible. So we import this particular feats from this. If you don't have this particular library installed in your system, you don't get to get this. So we import, these are the importation, you import feats, you import ARIA, import time. So we define a class PDF structurer. We define our constructor. So this is our constructor. We get to pass in the path directory, and then this status callback. Now, when we say status callback is equals to none, some of us who are very familiar with Python, we know that this can be defined from when we call it, or it may not. But if you don't write anything, like you don't assign anything to it, you don't get to do that. You must pass in a PDF file. But I must not pass in a status callback because I already declared to be none here. That means it can take any, we can decide to leave it. It can be empty. So after that, we do some definition of some global variables that we're going to be using throughout this particular script, where we define the path. We get with the path we just brought in the document. We open feeds. We use feeds to open the document through the path. Then we have stream. We define stream. We define collection and section. These are different things that we used in processing this particular PDF. So here we have the log file. This one is just to keep the log of the processes that is happening in our PDF. So we have level detection. So this level detection is actually the first process that our PDF gets to go through. Now you must understand that when you load in your PDF, the PDF just loading as a block of text, just pops in there into as a block of text. So it's not as if it's separated or anything. So this particular the text level is where we get to just manually have something like a guess. I think that's the right word. We guess if this is a header or a title or something by what we call a score confidence. We give it scores and then we use those scores to compare and know if we have a body here or we have a subtitle or we have a header here. So we say if font size is greater than or equals to 16, score is plus 3. Remember, we already start with score 0. So this is going to go through every text. Thank God for computers being as fast as they are. If not, if this was a human work, this is going to take forever. So this is going to be very, very fast as you might rarely notice it in small PDF files. So when font size is greater than or equals to 3, we give it a plus score of 3. Else we give it if the file size is greater than or equals to 13, we give it a score of 2. Then if 1 is less than or equals to the length of the text dot split. Now, the length of the text of each line, because this particular text is going to be each line of the PDF. So if the line is too short, then we call it a title. It's probably going to be a title. That's just the concept I worked with. So you might work with a different concept for you to structure your data to know which is which. So you can just come up with that, go online and go through this. You see that that's just the process I used. I used things like this font size, the length of each line, and I used all the letters capital. That's the purpose of this shopper. All the letters capital. If it's all capital, then probably it's like a title or something. So I just use call. I just gave them calls, and then I also gave some of them, if the length is greater than 15, probably this is not a title. I reduce the score and stuff like that. So you could do it your own way, the way you decide is best, no problem. So now extract streams. Now this particular function, what this particular function does is it extracts the page numbers, the pages from the PDF file. So this get called in the run section. You're going to see how all of them get laid out in the call section. So just like I told you, it's each line that we get to read. So that's what's happening for this. All this self.log is just logging in the different information, the processes, how many pages has been processed and stuff like that. That's what it gets logged in. So classifiers. So this is where we get to classify. Is this a header? Is this a subtitle, whatever? This is where we get to classify all of that. So all these ones are just structures for us to, are just callbacks for us to see what's actually happening in our system. So build structure. This is where we get to categorize them into sections, sectors, and different stuffs like that. Remember, there was something I actually did here. So now, because of the way I structured this particular system, I had to give it the chunk ID, things like chunk ID, title, give it sub chunk ID, so that I can be able to retrace my steps when I extract them. I can be able to rearrange those chunks back for me to be able to form the actual um, data that was split, because this particular system will break the document into small parts. It's going to break it into small but meaningful parts. So you could just go through this and make up your own. Remember, just like I told you initially, it's not rigid. So this is what our final chunking will look like, at least at this stage, where we have the chunk ID, the title, the subtitle, the content, and the pages. When we get to the chunking aspect, we're still going to break this down. We are going to have more metadata from here. So the run is basically the processes that get run so that we don't begin to call all those processes individually. First of all, we extract the stream. After extracting the stream, we classify them. After classifying them, we build structure. After building structure, we finalize the chunks. So this is just a function that when you call this function, it gives you everything that is going on in this particular script. So let's go to the chunking script. In the chunking script, just like I said, it's for us the max amount of words for each of the PDFs is 120 words. Then we also have what we call overlapping. Overlapping is by 30 words. That means, for example, if I have a sentence that says, "This is a boy and he's going to the river." Now, it's not going to be really nice for me to just cut it as "This is a boy," another one, "He's going to the river." I would like to cut it this way: "This is a boy." Then the second chunk should come from "This boy is going," the second chunk. Then the third chunk should be like, "Is going to the river." So it should have something like an overlap so that when you retrace the words, it can easily um, make sense to our vector, especially. That's the reason for this overlapping, so that when we want to extract, you can, have some kind of correlation, understand what's actually happening. So now, if the text that we get from each word is more than 120, this is where we get to create some sub chunks. Now, those sub chunks get to be assigned some kind of ID. So this is where everything, oh no, this is for login. So this is where the whole thing gets to happen. No, not here either. Sorry, please. This is where everything gets to happen. So we have the vector ID, the document ID, the chunk ID, the title, the subtitle, the pages, then the sub chunk index. So when we have one particular chunk and that chunk is being split, you're going to have 0, 1, 2 on it. So, but if a chunk is not being split, you just have sub chunk is equals to 0. So this will just enable us to be able to retrace our steps back. That's just what that particular this thing does. All these are just for to know the processes as is going on. This is one to is to know the process. Then when we want to export the data, this is how we get all the rag, um, the embeddings, or rather the chunks, rather, please. And then this is where we get to run our project. This is where we get to run our project. So let's go to the third script, which is the embedding. This is where the main embedding happens. So what are we doing here? First of all, we declare our class called embedding pipeline. We define our constructor, define the variables it takes in input data. Then it's also going to take in the module part. This module part is actually the embedding module. Remember, you don't use your normal text module to do embeddings. We have different embedding modules. We have the Ollama embedding modules. We have the OpenAI Hugging Face, of which that's what we're using here. We're using the All Mini LM L6 V2. So this is actually a fair embedding module. It's okay, you can use it, but if you actually want better embedding, you can use much larger um, modules, but this works just fine for me. So we can use the module part. We're just defining some variables here. Then finally we load up our embedding module. This is where we load up our embedding module. After doing that, this is how we load it with sentence transformer. We load the module. Then we have the embedding text. This is where we begin to embed each of the text by just calling module dot code, passing text, or passing normalize embedding equals to true. This is just a yes, a parameter among the what we're supposed to pass into the encoder, the embedding module for it to work function properly. So the run, this particular function is just bringing all these functions to one place so that we don't begin to run them one after the other. So this particular function just run all of them in the order they are supposed to go, right from here where we load the module. It calls in it after loading the module. It gets okay, this is all the module. It gets everything. So it gets the chunk also being loaded in. Then it begins to embed them, and as it's embedding them, it's saving them. So that's just it for the embedding. If you want to understand it more, go to the GitHub, get the code, study it better. So finally, after the embedding, the next thing is uploading it to our ChromaDB. So this is our ChromaDB part, the collection name, which is very important. The status, this one is optional. Then we also have the document ID, which is none, but it's always it's none because of the other things we're going to be using with it. But when we are uploading, we don't need to create a document ID because it's already created from our ingestion pipeline. Once we want to upload our files, it's already created there. So we just pass it in there, pass it into this place so that it gets saved in the ChromaDB. So this is just the different stages, different functions defined here. We have the load data from embedding pipeline. It's loaded here. Prepare data for ChromaDB. We just prepare the data. Add probably some more metadata to make it more explicit. Then we have the indexing. This is where the sorry, please forgive me. The preparing is yes, it's virtually getting it ready to be by appending the vector database, the embedding the text, just putting everything up to the uploading everything up to the database. So uh, this is where the main thing happens. Everything gets uploaded. These are just the metrics we use for checking what exactly is going on. The run DB is just calling everything together, load vectors, prepare vectors, index them, upload them. So after that, that's it the for the ingestion. So let's quickly go into the ingestion file. Everything just gets imported here. You just get to import every of those scripts that we've worked on. We import all of them into this place, and then we initialize the constructor. Once after doing that, once we've initialized the constructor, under the run, we begin to call all the constructors one after the other. We're calling the paster, which is the PDF structurer. After we've done that, we call the chunk. This is where we chunk the chunker. After we cut the codes into small, the text into smaller bits. Then we also have the embedder. This is where we convert those chunks into numbers. We convert them, we embed them within our embedding module. And then finally, this is where we get to upload it into our ChromaDB. Remember, self.link Chroma connection. This is just where we get to get the document ID from what was created in the app.py, get it and append it with the the collection name. So just like I told you, this callbacks is just telling us what is actually going on. So this particular place is just when I was testing. So that's it. So after that, finally we now get into the query. We have uploaded the PDF successfully, from extracting the text in the PDF to chunking it to embedding it, and finally we added it to the database. Now, how do we extract the information from it? How do we extract the information? So first of all, we initialize our constructor of our local RAG pipeline. After we do that, now we get two modules, which is the two modules we get here is this and this. This is for embedding our text, and this is for this is a module that kind of call it a re-ranker. Call it a re-ranker. It gives more meaning. I call it meaning. I don't really know how to explain it, but it kind of helps our module when our prompt is being when we ask a question. This helps our database understand the questions we asked, and be able to extract better answers from our ChromaDB. So this is where we initialize the both modules. After we've done that, all these ones are just initializing. This is the ChromaDB. Remember, this persistent client is for us to initialize the database in such a way that we can always reuse it each time we come to run the project again. So I think there are 3 different ways we can initialize the ChromaDB. So this is one of the ways that we can initialize it. Then we now have a token. This is this tick token. Now, many times LLMs understand better, just like I said initially, with numbers. So there is a level of preference. We have the long text, we have tokens, then we have the numbers, or I think there's semantic search or something. But for this project, we're using tokens, which helps our system understands better and be able to extract better answers, better context from our database. Remember, the reason for RAG in general, just like we said, it is retrieval augmented generation. It retrieves from the database. What does it retrieve? When you ask a question, it sends it to the database and it retrieves the answer. It doesn't retrieve the entire database, the entire PDF, but it just retrieves things that he feels that this could be the answer, 1 could be the answer, 10 could be the answer. It picks them, it brings them out, then it gets augmented. So the process of augmenting, that is what this um, tokenizer is here for. So we get the token controlled through through this particular, we count the tokens. After we do that, then we view the context. This particular context is to know how many tokens that we get to pass into our database. Remember when I told you the other time that we have to expand the query? The reasons for us expanding the query is so that we can, in case our user does not ask our question well, we use LLM to, expand the query to a more detailed question that would extract better answer from our database. So we are going to give our module a prompt like generate 5 semantic search query for the document retrieval rule, focus on likely document terminologies, use domain keywords, preserve original intent, avoid generic phrases, and stuff like that. We tell our module, please give us this question so that we can work with that. So from there we get our response. Remember, you must always tell it things like no numbering, one line, so that you can predict to some level the kind of answer that the LLM will give you. So you pass in your query. After passing our query, we get our response from text response, message, and content. So with the idea of what AI answer will be, that's what we used to do some stripping and some collection of the queries so that we can begin our systematic chart. This is where we begin our systematic chart, where we pass in the query, those 5 queries. Now this top K is equals to 50. That is the amount of results you should get from the ChromaDB is 50. So this is you can reduce it or increase it. It's all your choice, but 50 was something that worked well for me, and I think I'll stick with it. And then this is just it where we query our database. First of all, we have to encode our query. After we have encoded our query, then we use our query to extract. We use it to query the database, and database gives us chunks of text. So when those texts come out, those chunks come out, this is now what we now do. We now reformat those chunks back to this form so that we can kind of have a concept of what we are looking at. From the results document 01 and then metadata 01, we just extract the metadata and the document and the text that it actually replied us. So this particular block is just also for better categorizing of our answer. If I use that word, it's a better categorizing of our answer. So this particular place is just to re-rank our answers to the top 15, the top 15, the top 15 best answers. Remember that when our vector database gets queried, you get to answer us from the first most reasonable answer, second most reasonable answer, third most reasonable answer, like that to the down. So we select the top 15 at default. Remember, this is at default. This can change when this module and when this particular function is called. So we rank our queries, we rank them. Then we build a format. This is the format we're building here. The chunk ID, the title, the subtitle, the page, the chunk ID. So these are the things that we are going to be giving, we are going to be feeding into our module, or sorry, into our LLM. This is what we're going to be feeding to our LLM. So when we feed this to our LLM, if you look at this is the structure it will come in. This is the way the text will be. So this is the structure our LLM will understand our context that was extracted. So this is where we call our LLM, this particular LLM. This is where our question gets answered. You are a precise. So I did this particular this thing in two forms. This is for when you don't want to stream. This one when you just want the answer to appear in a block form. This is where you get to do that. Then if we want our answer to stream, this is the current one we are using, which is Ask LLM Stream. So we pass in the context, the question, and the module it should use. And then we pass it this particular system prompt, and then we ask it our question. So that is just that for that. We pass in the stream, then we get to run our entire project so that we don't get to start calling each of these functions one after the other. We just put all of them into this place. Now, just like I told you initially, if you remember above, we used 50, but in this particular one, we called the semantic search, we gave it that it should retrieve the highest 80, the highest 80 results. So it will get us the highest 80. So 50 was the default, but when we got here, we decided okay, 80, get us 80 of them. Then we expand them. Then if no block, no relevant data was extracted from the PDF, that means if no answer, if there was no similarity. Sometimes when you upload a legal document and you start asking the legal document questions about wildlife, you will see that nothing will be extracted from that particular PDF. So that's what makes this system so unique, because once you ask it a question that's not related to the PDF you've given it, it will simply tell you there's no relevant information found on the PDF. So now remember, we are extracting 80 top ranking context. So there is always bound to be repetition from 5 different questions, or rather 6 different questions. So there's always bound to be repetitions. So this particular block is what helps us extract only but um, unique chunk ID. So once any of the particular contents, maybe I've withdrawn one chunk before and another one comes out again, one chunk one, it doesn't, it's just one of the one chunks that I will get. So that's what this particular block does. Then this particular block helps us for our module to re-rank all our as in our chunks properly. Rank all our chunks properly. So this is it. We re-rank our chunks, then we get the chunk positioning. Get the chunk positioning. This is where we do all of that. Get all of the chunks arranged properly before we then finally. This particular portion is just to protect it, to protect our LLM, So if the number of tokens that is being passed into our LLM is too much, it should reduce it. So finally, our query gets sent to our Ask LLM stream. So that's just it. So that was it for the entire code. When you come here, you get to see how these are different PDFs that we've uploaded in the past. You can chat with them. You can ask things like, what is this document about? You get your answers. So that's it for this project, guys. I hope you learned a ton and hope to see you in future projects. Just like I said, this particular project is not for Python beginners because I literally did not explain the codes in so much details. I just ran through the codes. So if you want to get a sample of the code, the link to my GitHub is under the page. Just feel free, go there, download it. Do make sure you always install the requirements.txt, the modules that you need so that we could run the project more easily and smoothly. Alright, that's it for this. Take care.